Hello there. I'm going to show you how to do the particle surface flow simulation and get swirling particles like this over the surface of any geometry. We're going to use the particle node modifier for this. It's going to be super simple and quick. So let's get started. I'm in a new empty project here. First, we need some geometry to work with. So let's add the text object. Change the text to whatever you like. You can increase the depth amount as well. Set the alignment to middle. And change the font style to bold. Bold looks better. Put this text under a connect object. It's going to be much easier later when swapping the geometry. Rename it to mesh and turn off the weld option. Let's do the particle simulation. Go to the Simulate menu, come down to Emitters, and choose the Mesh emitter. Select the emitter, go to the Emission tab, and you can see our Mesh Connect object is already here in the geometry field. If it's not here, you can just manually put it. Come down and change the particle emission rate to something like 10,000 for now. Go to the Properties tab and check this Lifetime Limited option. Set the lifetime to be around 80 frames with a variation of 20 frames. Remove all the speed. Play the simulation. You can see the particles are emitting from the mesh. I'll increase the length of my timeline. Select the particle group. Turn on draw radius and reduce the size value all the way down. It's going to make it easier for us to see the particles. Let's add the particle node modifier now. Put it under the particle group. Go to the Fields tab and add a random field. Turn on View Plane Preview. Make it flat. I'll just move it up. Position doesn't matter. Now turn on these values. These icons represents the field's value, color, and the direction. Go to the Field tab, scroll down, change the scale amount to something like 600. Add some animation speed. You can change the seed value. Now move to the Remapping tab. Scroll down and change the contour mode to curve. Then adjust this spline curve like this. You can play with this as much as you want. Yellow color means more influence and red color means less influence. Go to the Directions tab and change this to Normalize. Now you can hide this random field. Double-click on this particle node modifier icon to open the node editor. This is where we're going to build the logic. First, we need a reference or link to our geometry. We need to add an input for that. So come to this left side. Right-click, go to Add Input, and select this object link. We can now link our geometry. Minimize this. Select the particle node modifier. Go to the Inputs tab, and here also you can see the Object Link option. Drag the mesh here, and come back to the node editor. Double-click here to open up the search, and look for the closest point on surface node. Make sure you select this one. This node, for each particle, finds the nearest point on our linked surface geometry and returns the position along with the polygon index as output. So first, let's connect our linked geometry to it. Now we need to connect the particle position. Now look for the Generate Point Normals node. This will make sure our geometry has clean, smooth normals. Feed the geometry to it. Now we need a Mesh Property Interpolate node. This node takes the polygon index and position from the closest point on surface node and smoothly interpolates any property from the mesh at that exact location. In our case, we want to interpolate the normal vectors. So connect these nodes. Connect the point position. We need to connect the polygon index as well, but there's no output port on the closest point on surface node. It's hidden, so let's bring it out. Right-click on it, go to Add Output, and choose the Polygon Index option. Now we can connect them. This will give us smooth and accurate surface normal direction under each particle, which is necessary for creating the tangent flow. Also, change its type to normal. Get a range mapper node. Change its data type from float to vector. Connect this field direction data coming from the random field to its input port. Now we will do the cross product with the outputs of these two nodes. So get a cross product node. Connect them. This node takes two vectors and outputs a third vector that is perpendicular to both. This is what creates the flow direction that follows the surface without pointing outward or inward. Add a scale node so that we can increase or decrease the flow strength. Change its data type to vector. Connect the output from the cross product node to the first slot. And we can connect our custom float value to the second slot. So right-click on this side, go to Add Input, and select Float option. Right-click on this float input and go to Edit Port option. This opens a new window. Here you can change its name. I'll change it to flow strength. Leave the data type to float. Check Show Slider option. This will add a slider to this input. Check Show Slider Limits. Leave the minimum to 0. Set the maximum to 1000. Also, set the default value to 80. And you can close this window. Now we have a custom input with a slider. Take this flow strength and connect it to the scale node. Connect the output of this node to the particle velocity. Save your project and close the node editor. Run the simulation. You can see that it's working. Particles are swirling around, but they are not completely sticking closer to the surface. So let's fix it. Go to the Simulate menu and add a Surface Attract modifier. Leave the radius the default. Increase the attract amount to 2,800 and follow strength to 1,000. And add some damping. We also need to add a collider tag on the mesh to make it work. You don't have to change any settings here. Run the simulation. You can see the particles are sticking to the surface and swirling around. We're getting a good surface flow. Add a data mapper now. We'll modify the radius of our particles with this. Change this property from age to velocity speed. These values are good here. Change this property out to radius and modify these values. Select all the points in this graph and change the point type to ease. Run the simulation. Now we have some smaller and big particles based on their velocity. Add a color mapper modifier to make it even better. Come down and change the property to velocity speed. Choose a good gradient preset, or you can make your own. Run the simulation. And now the particles have some color. You can take your time to tweak the gradient as much as you want. I also added some turbulence forces to make it a little more interesting. So that's all for now. You can download the project file from the link in the description. I hope you liked this video. If you did, leave a comment and like. And if you're new to my channel, you can subscribe for more interesting contents. If you want to support the channel, you can become a member on my Patreon and you'll get early access to my videos. See you next time.